Sharon, can you see my screen in the full screen?
Yep, I can.
Okay, okay, so I will start. Okay, thanks for attending today's webinar. I didn't know that today is a holiday because somebody noted me that because today is a newly is a newly appointed by the some Biden administration or whatever because it started quite recently. And then nobody actually noticed today's holiday. But anyway, today's webinar topic will be AI, large language model, and XR, extended reality power. These are twins in healthcare. We are going to have a three speakers, including me. So I will start first, and then we'll follow by Sharon Zhang, co-founder and CTO of Personal AI, and hopefully Mylane and Drew, because he is in India, but hopefully he will join on time. So she's a co-founder and chief medical officer in Predictive Care. Okay, so today's topic, I will talk about two topics. First is the overview of digital twins in healthcare. And then I'm going to particularly that I focused on digital twins for mental health that I've then currently focused on. And then Sharon will talk about healthcare application of personal AR digital twins and Mylane, and then talk about DNA-based digital twin, the practical AI and large language model applications. Okay, so first, because of time limitation, I prepare a lot, but I already shared my presentation in my LinkedIn post, so you can see for details. So I skim over only touch the essential part of my presentation. So overview still is a big topic. So in general, the digital twin is in healthcare means a virtual replica of physical entity. So it's a physical entity, usually patient and medical devices or the entire healthcare system. And this replica use real-time data. So data is very important to simulate, predict, and optimize various aspects of the healthcare delivery and patient management. So particularly, primary purpose is to simulating. So disease progression and treatment response can be simulated and predicting. So outcome based on real-time data and historical trend and optimizing and the healthcare process for individual patient treatment or hospital operation totally. So key data source, the data is a key in digital health in application of the digital twin. So for example, electric health record and genetic information and wearable like data and environment data, all data for the healthcare required for the digital twins. Okay, so our key components are usually the physical entity. So the digital will be the twin of the physical entity and virtual entity with the twin. And virtual model, the digital model is required and they connected. So the virtual and real will be connected through the network and they'll be communicate. And then digital twin data, so data input and output. And then service. Service means that the what kind of like a purpose of the operation your digital twin. Okay, so for our use case, the first one is precision or personalized medicine. So disease simulation and treatment response. So digital twin can simulate how a disease will progress in a specific patient and how different treatment might impact the progression. And this allow healthcare provider to observe potential outcome to various treatment scenario without any risk to the patient. So for example, in oncology, the like a cancer treatment, digital twin can simulate the effect of different chemotherapy. And so actually that they can assume that the condition of the patient, and then they can like simulate the patient condition on the treatment. And then it can be like provide the valuable information to determine the best option of the treatment and the best option of the like a drug treatment, something like that. And then there is a tailoring drug doses. So this is another aspect you can think about it. And another the big area that digital twin is contributed is surgical planning and simulation. So this is a you have seen a lot of the news media cover this one. Recently, there was a news about the digital twin of the patient hurt. So patient actually modeling the patient hurt and then simulate for their surgery and then looking at the detail aspect of the part of the disease part of the like the hurt, and then it can be like a make a planning of the surgical procedure. So this is a very powerful tool for the in surgical planning and simulation. And particularly they can use in the remote surgeries, a very promising area. You can employing all kind of like a sensing technology, including XR and then touch and other sensing technology can use for this kind of remote surgery utilizing digital twin for the patient. Okay, so another thing area you can think about drug development in clinical trials. So virtual testing is enabled. So in not only the is developing in drug this new drug, it will take a long time and then cost a lot, but a very complex process, and then it'll be made easier. Do you have like some targeting like a symptoms of a disease for your developing drug, and then you can test over that digital twin, and it's a risk-free and very flexible, and then it can reduce cost and a lot of advantages you can have it. And then and particularly the clinical trial require a lot of the like effort and gathering the like a patient for targeting patient and the population and the cost and all kind of complexities happen. So it can be made easier if you can utilizing digital twin for in the clinical trials. And then there are some effort actually FDA now try to permit this kind of the like clinical trials utilizing digital twins. So some of the startup and big companies are already working on that space. And rehabilitation and physical therapy and even not just for the patient actually in the hospital of operation. So yeah, this is kind of like a traditional in industrial digital application. You can think about like a effective use of the like a digital twin for the process optimization, like for example digital transformation of their factory or something. The same thing. So your operation efficiency for the hospital operation and resource management, you can cost a lot and you can maximize your performance over utilizing this kind of the digital twin technology. And then how to build this one to implement. So you require data. So you need to collect data. So source of data, wearables, and medical devices, and EHR and patient report data. And then you should integrate all kind of data for like a physiological data, behavioral data, environment data can be integrated. So data integration, gathering and integration is most essential part of the implementation of digital twins. And model development, so usually utilizing AI. So AI algorithm using the data analysis, predictive models, continuous refinement can be utilizing AI. And then once you have it, you can build the digital twins. So initialize baseline data for patient health record, initial assessment. And then it can be because there is like a feedback loop where you have a connection between the real entity and the virtual entity. So it can be like applied new data and then be iterated, whatever you have outcome, and then you can have a dynamically updating your data and your model. So this is one feature you can utilize in digital twins. And then integration modeling. So real-time data integration is very important. So data stream or the real-time data from various sources are continuously integrated with the digital twin is very important. And how much actually accurately because this is represent of your real entity by the virtual entity by data. And so actually how actually you can make as precise as possible is very important, and continuously feedback loops. So you can interact with the digital twin and real life like a like a situation, and then you can connect them and then and dynamically readjust your digital twin and then and feedback to your real life state, and then back and forth, and you have continuous feedback loops. Okay, so and then simulation analysis. So usually the machine learning utilized. So the modeling has outcomes and the practicalities and scenario. And that's usually the scenario modeling is very important. So you can planning something over digital twins, and then under certain scenarios you can test your model. For example, you want to like a test against like a particular treatment will be effective or not, or the particular drug will be effective or not, or a particular procedure of the your like a surgery will be effective or not. You can make some scenario and then test your over to your tooling, and then you get the feedback, and then you adjust your real life things, you process whatever, and then feedback again, and then you make optimize your process. So this is optimizing treatment plans or decision support. You can have it. Okay, so particularly large language model recently have focused because of its nature of it trying to over huge amount of data, and then you can fine tuning for a particular space. And this is a recent trial in UK hospital that they utilizing the EHR data of the patient, and then and using the data set, and then they make a time sequence digital twin model, and then they want to predict in the some time of the future what will be the like the disease progression over time. So this is very promising. Still, you should be know that the still the large language model is not highly accurate and then highly risk-free for apply for very critical in healthcare application, but it is very active research now, and there are many startups trying to do their best to get some result that actually can be viable, can use in healthcare application. So this is a promising space you can think about in the future. There will be some viable practical solution can be available. So this is one like some way to actually you get the EHR data, and then in the fine tuning your large language model, and particularly for the time sequence data, and then you apply for the what you have in the future. So this is general, and then you can apply some specific disease. And then the issue and challenge, yeah, definitely. This is data is very good. Data privacy and security is very important. A lot of you already know about it. And interoperability, yeah, this is another thing that because they integrate a lot of data in IT health and health IT system over, like for example, like EHR systems still they are not like interoperable among all different type of the EHR system, and then different IT hospital or the different healthcare IT system is not comparable. So there are some standard way to actually like exchange the data, but still you need to be integrate everything in the interoperable. So this is one challenge you should be think about it. And then so accuracy and validations, yeah, because this is a healthcare application, so you should be very careful about what is actually the what is happening the real world data happen once you have a successful in the simulation, and then you should be continuously validate and then defining a model, and this is a thing that you need to be very careful about it, and also like ethnic consideration. It is like consider about the data of the patient. So you should be thinking about avoiding like misuse of data and other things to think about it. And particularly infrastructure resources. For example, you wanna like simulate over like even the one patient of the whole his previous health record or health related data to require a lot of computing power and data resources management. So this is one you should care about it. And then so in the future, yeah, definitely we'll have enhanced predictive capabilities. So, for example, for Internet of Medical Things, so all the medical like related equipment in the hospital, in digital home, and other like sensors, in personal sensors, everything will be integrated in the future. So it can be available for utilizing the data to the construing some proposed data twins for healthcare application. And yeah, definitely like a large language model and other digital technology have improved in the accuracy and predictive power. And then particularly advanced AI where it can be make more better modeling of your digital model. So particularly, for example, biological interaction levels. So there was actually the our third speaker that will talk about DNA level digital model, the digital twin model. So we can think about in the like a molecular level like approach for these digital twins. And another thing that you can think about is they can be applied in the personalized wellness program. So in the future, maybe every individual have their own like individual digital twin. So it can be utilized for many things. Like where it can be tested over like whatever new drugs coming out or whatever new treatment coming out and what it have in the future, so it'll be like individualized health planning will possible. And the proactive health management for individual person will be available in the future. And particularly the integrated genomics. So at the genetic level, like a treatment and genetic level application will be available in the future. And then also they can be utilized for the monitoring and telemedicine. So it'll be much better way to expand into doing remote care, and they will provide a continuous care for in particular remote monitoring telemedicine is recently I heard that like FDA have some special task for this kind of effort. So the digital will be the key role in this space. And definitely regulatory frameworks, we need to build like robust guideline, and then patient safety and ethical use will need to be in the future. Okay, so particularly I'm going to focus on very briefly touch over for 5 minutes for the digital tool for the mental health. I'm particularly this because I already mentioned that digital tool can be leveraged in any kind of situation for your health condition and entity, whatever. So particularly that I'm interested is like a brain. I'm particularly interested is the digital with your brain, right? So usually that in the brain that if you can have a maybe it may be impossible to have a perpetually model your brain, right? It really requires a lot of data and information and computing power, something like that. I know that there are very promising effort is going on like on the like NSF or NIH, like a future endeavor, like making your full brain model, like a digital brain model that I heard about. There are promising researchers already working on that, but anyway, but in some part actually you can like utilizing your whatever you know about your brain, and then you can utilize data, and the AI can make something. Particularly, I'm very promising about is like for example cognitive state and the mental state and neurological state of your brain will be the future of the like hot topic. And then particularly you can make a mental health, right? So you can think about it's a mental state, right? Because whatever you think of a mental state, so usually you have your brain have something to the mental state. A mental health usually you have a stress problem, you have PTSD, you have a depression, and many things you can think about it, right? So that kind of thing, you have already accumulated data in EHR or the clinic data and the utilizing data, and then you particularly integrate the other data and psychological data, you can construct this digital twin of this mental state, and then you can think a lot of things already about talk about it, right? So this is very similar. Particularly, I already provide the general approach for how you implement digital twin. So you will be more fine tuning about particularly targeting mental health cases, but the processes are very similar. And then I already share my presentation, so you get it a detail about it. Right. So particularly I'm interested is to how to apply this digital twin of the mental state to the developing the design of the new digital therapeutics that I'm really interested in and focus on this area. So the digital therapeutics is a way of the like providing digital means usually the application software to treat mental health state. And then recently I focus on this space and then I analyze all the industry and then I found that particularly among in the ecosystem of DTX, the mental health space is the most popular one. And then I found that more than 60 startups and working on developing new type of DTX. So utilizing digital twins for this space will be very promising that I'm interested. Okay, so I done my talks. I will stop sharing and then I pass over to Sharon about her fascinating topic. Sharon, you can start now.
Everyone, nice to see you all, and thanks for having me today. So today I'm actually going to be talking about personal AI digital twin application in healthcare. Um, so let me start the presentation. So just briefly about my background in healthcare and AI. I spent about 16 years in AI, kind of dating myself here. 7 of them are in healthcare. I spent my starting of the career in nuance communications, building out EHR, medical transcription, actually building out specific clinician models for each of the clinicians that we had. I think there was 200,000 of them that we were building daily models for. And a lot of that work inspired Personal AI today. Also worked with Kaiser Permanente, Department of Research on both clinical and operational side. Did predictive analytics for readmission rates, how to eliminate or reduce that, and also worked on just predicting certain cancers out of the pathology reports as well as heart disease. Spent last 4 years co-founding and building Personal AI. We are both a consumer-facing as well as a B2B-facing product. For the B2B sector, we largely operate on 3 verticals. One, of course, is healthcare, one is legal, and the other one is finance. So this is my agenda today. I think Alex already covered a lot of the first point, which is what is a digital twin as defined by the wider definition acceptable today. And the second part, I wanted to spend time on, what does it mean for us building a digital twin of a clinician at Personal AI, and really go under the hood a little bit of how we build this. But last but not least, it's my favorite part, which is talking about customers and use cases that we have been seeing in healthcare thus far. So the first thing, of course, is what is digital twin? I did want to open up the floor a bit. If you could use the chat functionality, just answer these 2 questions, maybe take like 30 seconds. First, what does a digital twin really mean to you? And then second one, how would you use your digital twin if you had your own? So just wait for 30 seconds for everyone to do the process and answer. All right, I'm gonna move on. I think Alex already talked about this in detail, so I just briefly reemphasize again. Basically, a digital twin is a digital replica of any object, process, or person. And of course, being Personal AI, we're definitely replicating the person entity. The second part of it is I love how it was emphasized that this means you want to connect to real data sources that in real time and being able to update in real time to predict based on both current and historical data. So those things I think also are very important. Second, I want to talk a little bit about like what does a digital twin mean to us in the personalized space. So first, what is a personalized digital twin? What we do is we build private models of an individual or an organization. So there's three things that we really care about. The first thing, of course, is accuracy to your memory or your information. So this is really any kind of data that you might consume into your personal AI or your organization's personal AI. The second part of this is we want this to be authentic to your mental models and your communication style. So one big use case for personal AI right now is essentially retaining information, recalling information, as well as communicating that information and sharing it with outside world, whether that's other patients, clinicians, or your staff, right? So this is essentially how we think about building a model of you. And the third is really thinking about this side of attribution. So what I mean by that is if you imagine an LLM, or even if I build on top of the data of everyone here today, right, you will get a general model where it's very difficult to tell who has said what, which mental model belongs to Alex and how he diagnosed things, and which mental model belongs to me and how I think about things, right? So we want the reason why we build these individual models is because then we can say clearly who has had these thoughts and really encourage that diversity of thought. And then the second part of this is really connected to the real-time data source part, such as where your documents may live, your emails, your other communications through SMS or other messaging apps, to create that essential memory for your digital twin. And the second part of this, I think Alex also mentioned a lot about the continuous nature and really learning from the real-time feedback. So for a large language model, especially fine-tuned models, it's very hard for it to adapt to real-time information and incorporate real-time knowledge rapidly, right? So the system that we have built is that you can adapt to any kind of user feedback in real time, and it's directly integrated into the model itself. So why have one, right? So I like this illustration because it makes it very clear LLM versus what we're building, which we'll call a personal language model for the individual. So really, LLM is an aggregation of all the world's knowledge based on, the medical data corpus, right? So what we want to build is mimic the mental models of each person, and you can still have the benefit of querying all of them at once, right? Except for you would get individual thoughts rather than a aggregation of thoughts. And the second part, I want to talk about like, why do our users come to us, right? And the first thing is that proprietary knowledge is very important. So if you think about the different industries, whether that's healthcare or law, legal, as well as finance, there's a lot of proprietary knowledge that is private to them. So they want to keep this data private and confidential, right? And this data is also very difficult to get from a public corpus. The second thing is they want to scale communication, right? One is to have their staff or their clients or their patient being able to access their brain 24/7 without them actually staying awake 24/7, of course. And that's via email, SMS, or direct messages that they can have this 24/7 interaction with their patients or their clients. And the third thing is, right, you may ask, like, why would I want my AI to represent me and maybe sending wrong information to some people, etc., right? But what is valuable is that you have full control over whether the AI responds, when the AI responds, and then you also have the control to modify the response before it's sent, right? So imagine scenario where I'm asking my doctor a certain question about my past medical visit. Then my doctor actually have the chance to review that response before he or she sends the response. So that's how the system is constructed. And of course, once they modify the response, that's actually going back into the feedback loop to be learned on for the digital twin for the next time. So how does it work? A little bit under the hood. We talked about the sense of real-time data and memory. So that's everything that is proprietary knowledge, that's social interaction from your messaging, that is author data. For example, if you are a clinician who also write books, those books can go into their research papers, et cetera, et cetera. Second thing is the model, which is kind of your personal AI. When we talk about authenticity and really being able to measure the transparency and accuracy of the model, we really approach it from 4 different dimensions, and we score each of the AI responses based on these 4 dimensions. So the accuracy score would indicate how accurate it is to your memory, whether it's directly coming from it or there's some interpretation on top of it. We're also measuring things like communication style, fluency, and relevance to the patient, sorry, to the user, sorry. The third and the fourth thing is how would you then take your personalized somewhere else, right? So we have both the API integration, which some of our customer uses to embed into their product. And we also have native applications that we have developed, which I will show a screenshot of later, that operates both on mobile web app as well as desktop app. So this allows the users to actually bring their community and have real-time interaction, managing both their memory and their models. And then this is just a deeper conceptually how this will work, right? So the step 1 is really training this personal AI or digital twin of you. So this is by adding any type of memory, by sending messages, or really just connecting your data sources. The second step, we think about engaging with your AI and then trying to improve the personal score that we're just talking about. So once your personal score hits a high, 80 and 90, it becomes a very accurate model for that specific topic or response. And the third step is you will review this co-pilot responses, what we call it. So these are essentially responses that your AI has drafted for you, but has not sent it. And once you review and edit these responses, it goes back into the tuning and reinforcement learning of your digital twin model. Okay, so now is the part that I'm most excited about, which is really talking about 2 use cases in healthcare. One on the individual digital twin level and the other one on the organizational digital twin level. So the first person I'm going to introduce is Paul. So Paul has been one of our early users for a very, very long time now. So his pain points is really he has a lot of cognitive overload for patient care because he runs his own clinic. He has to communicate with patients. He also have a lot of students who is coming to him to learn more about how to pass like American board exams. And then the second point is he has always stay up to date on the current researches in wound care, which is his specialty, and really understanding how that clinical protocol will work and operating in the bounds of that, right? So instead of me telling you how he is using Personal AI, I'm gonna let him tell you himself. And please let me know if you don't hear the audio.
I could put in clinical scenarios. And then I would personally tell, in these cases, I want to treat, this is the algorithm that I want to use to treat this patient. So when I run into that situation, I could feed it in, and then it will tell me, okay, this is how you want to treat this. So just by having that information available already, I'm already thinking less. It's kind of like using the system to kind of help me guide there. But then now I'm telling it, okay, if you run into these cases, here's how I want to treat it. So then I feed that information in, it'll feed back, says, oh, okay. And they say, okay, what, the office staff may get a phone call from a patient and they say, okay, what, they would call us, say, what do you want to do now? But what one layer you could do is share that AI persona. They could do a triage on, here's his thought process on how he wants to treat this situation. So then it will reduce. So then you get that over and over again. Then it will reduce. It'll make the practice more efficient because they could, in essence, want to say read your brain. You're already telling it. In these cases, here's what we do. Here's our protocol on it. So that's where AI becomes part of it. I could put in clinical scenarios.
Well, okay, so Paul mentioned something called AI persona. I just wanted to briefly go through that, right? So this is how Paul's digital twin looks like, and keep in mind that he is an individual person with an extended team in his clinic. So we have this concept called the primary AI. So essentially, primary AI is a union of all of your AI personas. So think about each AI persona as something that manages one group of data for you, and you want to share that persona with a specific group of people, right? So the first use case that he talked about is using his persona as a digital clinical companion, essentially feeding it clinical protocol scenarios, how to treat patients, and then being able to share this persona with his team. So when his team are getting questions, they can directly tap into, I guess, a digital Paul without having to ask him the same questions all the time, right? So that is one example. And of course, you can have other personas under that primary as well. One of which is, I mentioned, he operates as a medical teacher or a coach for people who are coming into the United States and then trying to pass the American bar exam, right? So he can share with his students 24/7 advice on like how to do best practices, FAQs, how do you approach these type of questions on the American bar exam. So that is shared with a different people as well as a different corpus of knowledge. And keep in mind, all of these personas have their own separate memory stores, and so they've never crossed with each other. So the next use case I want to address is more of a operation use case. So Lean 365, they're a clinical operation continuous improvement firm. Essentially, the pain point of their clients, which are these hospital entities or departments, is that every hospital goes through these very specific process improvement project every year. So it takes around like 3 to 4 months of a group of people's time to be able to do that, right? And the other pain point is around 80% of these projects already done before in the previous years. It's just they're on paper, or the person who has conducted them has left the hospital, so no one knew, right? So essentially they're wasting resources on repeating the same type of projects every year. And then their use case is that each of their clients, so each of these hospital entities, have a very specific knowledge and implementation plan on how they want to approach, say, how do I optimize wait time in emergency room, right? And then they also want to solve this discoverability of past projects so they don't have to duplicate efforts, or they can get directly into the implementation rather than the discovery and planning part of it, right? So the ROI they're really seeing is being able to shorten the project timeline from 10 weeks to 7 weeks, which essentially eliminates the 3 week of discovery time. And that is equivalent to a time saving or monetary saving of $10,000 per project. And this is what a Lean 365 organizational digital twin will look like. So Lean 365, which they name their AI Sage AI, would be sitting on the top. So this essentially encompasses the corpus of all the different hospital entities under it, right? So for example, hospital entity 1, A, and B could have different PDCA procedures, different projects they have done in the past, different ways and different owners of the project that they want to approach, how to do their future projects, right? So each of these hospital entities essentially will construct their own digital twin managed by Lean 365, right? You can also go down to the department level where you're capturing emergency room specific PDCA procedures that's relevant for that, right? So in this case, the data and the scope and the model would be only under that emergency room department. So I hope that's clear. The last but not least, I just want to emphasize that the same thing Alex talked about, really, I think in healthcare, legal, and finance is very important to really understand who is owning the data, are they training on the data, how the data is being used. Once you're giving these data to different modeling companies, And also compliance and privacy is a huge part of this. So understanding how the data is protected or how your patient's data is protected is very important. And of course, just to be transparent, we're not yet HIPAA compliant. We're very close. So we're going to be doing that in the next month or so. All right. Thank you. And if you want to know more about the healthcare use case for digital twins, please head to personal.ai/help.
Thanks,
All right,
Sarah.
back to you.
Okay, next speaker is Mylene. Mylene, are you there? Okay, I already talked that she is in India in the evening time, but okay. Yeah.
Yes, I'm here.
Okay, yeah,
Yeah,
fine.
back in
Yeah,
the Bay Area.
yeah.
So it's very good to be here. So hi, everyone. My name is Mylani. I'm currently the Chief Medical Officer of Predictive Care. And today I want to share with you basically our journey through the world of digital twins, AI, and most recently LLMs, which are really changing the game in healthcare. So I hope you can find some inspiration with your work or your personal health journey, hopefully at the end of this 15 minutes. So who are we? Just want to rewind a few years back. So it started when I first met our co-founders, which is Sajung and Sijung, during my time at Johns Hopkins. They were my mentors, and they also happened to be physical identical twins. So in essence, I guess that makes them qualified to be experts in digital twins. For us, we define digital twins or DNA-based digital twins as a powerful tool that's rooted in your genetic data, and that's really where expertise is. We combine this with medical and lifestyle data to predict disease risk and also create personalized treatments, as Alex had mentioned earlier. So what is our why? So Sajung and Sijung got into this field going back 10 years ago. Their father was diagnosed with stomach cancer at 52 years old. And being that they were researchers at the NIH in bioinformatics, they put all their efforts to find the answers in his genetic code. And sure enough, they did find a variant linked to this rare cancer. However, at the time, treatments were really limited. So chemotherapy wasn't an option anymore for him, and they had to perform a full bowel resection. And luckily, it saved his life. And as you can see here, has this time to spend with his granddaughters. But what happened here was it really lit a fire inside of Sajung and Sijung, and that's kind of when I met them. And they promised then to pave a way or a path to make this technology available, not just with research, but to everyone. And that's where we are now. So initially, we called our product DNA Health Map, which was, from our vision, it was going to be a blueprint, kind of like a GPS to guide you to your best health. And what we soon realized is health data is pretty messy. And I think our audience is pretty familiar with that. It's really like a puzzle piece that don't quite fit together. We're dealing with genetic data, huge data, dealing with gene disease associations, disease phenotypes, medical histories, and they're all coming from different parts of the health system. So we really had to zero in on like the bottlenecks and going back to what we know, which is the genomics workflow, we looked at the variant curation, which is really a fancy way saying we had to deal with a ton of data and find the most important stuff in research and clinical practice. So here's how we did it. We first collected the data from multiple sources. They're very dirty. You combine these and then you clean them. And that's when AI really helped us. And again, also with the analysis, once the data is cleaned, we can really leverage this technology to identify these patterns and insights that we ourselves couldn't do. So now we're at the stage of applying these insights on how to predict health outcomes And we're at the stages of validation and putting this forth in the clinical setting. So as we were building this database, we realized we were really creating something much bigger. And it was kind of how it evolved into a DNA-based digital twin. We realized this database, which lives in virtual space, was really living and breathing, and it evolved in real time, shaped by latest research in genetics, also by medical histories and lifestyles from our patients as they come to us with different signs and symptoms over time. So now we can talk about practical applications of this, and I know Alex and Sharon has touched upon this. But for us, this is how it works. We basically look at your genetic data, looking at the tiny variations that make up your DNA. And we also wanted to combine this with your lifestyle habits, your medical history. And again, putting this puzzle together, we believe that genetics is really still at the early stages of putting it to use for clinical practice. But with whole genome technology, you really only need to do this once in your life. And what happens is it changes over time as your signs and symptoms may present later in life, and as we know more research down the road in the future. So with this information, we can run simulations to predict your risk of developing certain diseases, take cancer, diabetes, and right now our focus is really on cardiovascular diseases. So when we, identify these potential risks early on, I think everyone can know the conclusion is we can then prevent and manage these conditions so that they don't lead to a more deleterious disease. So I just want to go back again of what led us to this. And COVID-19, I can't believe it's been almost 5 years when everyone's world really was turned upside down. So it feels like yesterday. But during this chaos, something remarkable really happened because people started sharing their health data like never before. And this time it was clean and organized. And for us at Predictive, it was a game changer. We saw this opportunity to put our expertise in predictive medicine to test. So the FDA at the time launched a challenge to develop AI algorithms that could predict COVID patients' length of stay in the ICU, as well as their mortality risk. And so we jumped at that chance. Our team also leveraged patient medical histories and medications lists to create this powerful tool. And it was designed so that they can anticipate which patients were at most risk, and so they can allocate resources accordingly at the time. So we realized, though, that integrating genomics data with health records, we can even take these predictions to the next level. So it's really adding the missing piece to this puzzle. And then the picture really is more clear, and we can see even more patterns that were hidden before. So take for high blood pressure as an example with chronic disease that, again, we're focusing right now. Many of you may know that developing high blood pressure is influenced by your genes. I see a question there about GWAS. Now, having a tool that could predict your likelihood of developing high blood pressure, we picture it like a credit card simulator that predicts your financial health. And we can use this predicting your risk for high blood pressure. And that's exactly what we've developed. So say you exercise 3 times a week, how is that going to affect your high blood pressure over time if you make these changes? So our patients are able to simulate themselves using this data and information. So another avenue that we're exploring is disease prediction is pharmacogenomics. And again, Alex has also touched upon this, where we're using real-time data for medication response and symptom management in the treatment of high cholesterol. So we currently have a study underway in the UAE to explore the feasibility of implementing this into the clinical practice. And the beauty of this is it actually is not limited to high blood pressure. Because we have whole genome sequencing data, it can be applied to a wide range of chronic diseases. So based on the digital twin, we can also predict how a patient will respond to certain treatments. So this helps in selecting the most effective therapies and minimal side effects. So we all know traditionally a doctor, clinician would prescribe standard treatment that works for most people. But we know we're all different. We all respond differently. It's almost like running separate clinical trials for you as individuals. So this hits home a personal story for me. My mom was diagnosed with high cholesterol, and she was prescribed a statin to lower her high cholesterol. And millions of Americans and international populations on this medication. Well, her body didn't react well, and she had severe muscle pain, so bad that she stopped taking the medication altogether. So from a clinician's perspective, this experience taught me something important. And the real cost of medicine isn't just about the price tag, it's about the trust that we place in those medications. And high cholesterol is a sneaky silent killer, but when the treatment causes more pain than the condition itself, just like my mom, patients are forced to make a tough choice and they just stop taking these medications. And we deal with those outcomes later down the road. So this is where we're trying to really utilize the digital twin, and we think this is a low-hanging fruit for us, where you can see or create this virtual replica of you and simulate how you may respond to various treatments. And I say it's low-hanging fruit because there's actually a lot of research right now and current clinical guidelines that are not being used in a clinical setting. So, and with Alex's presentation earlier in mental health, there is actually mental health has one of the most clinical guidelines pertaining to treatment and efficacy of medications by looking at a patient's genetic data. So we stand, at the healthcare revolution, trying to figure out where this is going to take us. And we know this journey is not going to be easy. And it's like climbing a mountain is what we say. And this is kind of where we are now after we've developed the product. How do we get this into the hands of our doctors, our clinicians, and also our patients? And so it takes a lot of persistence and a lot of teamwork. So AI and LLMs, Sharon has kind of addressed this with her recent presentation and what they're doing right now. And we've also kind of dabbled in this because we realize we really need to get this at the forefront of care. So by integrating LLMs into our digital twin platform, we can address some of the pain points of our clinicians, like what Sharon had talked about earlier, and create this bridge between the doctors and the patients. So making communication more effective, natural than ever before. So it captures and analyzes patient-physician conversation. So imagine discussing your symptoms with your doctor in real time. And the AI LLM processes your genetic data, which is housed in your digital twin, with your medical history, with your family history, with your current medications. And as this occurs, you're suggesting possible diagnoses and treatments based on all this information in the background. So by bringing these technologies, we're really helping our clinicians, along with AI and LLMs, to quickly analyze vast amounts of data. I mean, sifting through your genetic data, we take maybe an hour, 30 minutes to an hour to review all of that before we can even talk to the patient. So imagine that there's a tool that kind of helps you triage all of that. So as you can see, we're just getting started here, and the endless may seem really, or the possibilities may really seem so endless. And the road really ahead of us involves strong partnerships with health systems, getting buy-in from institutions, creating new ways to pay for and reimburse these cutting-edge treatments, which is one of the biggest challenges right now, as well as adoption for by our clinicians and health systems. So one quote that really resonated with me when I was in high school that I want to share with everyone is standing on the shoulders of giants. So the Human Genome Project started back in the 2000s. And with NASA's digital twin use with the Apollo 13 mission, this technology has been here. And it's just a matter of putting it together. And now we believe is the time. So here I come really with you to invite every single one of you, whether you're a researcher, healthcare provider, policymaker, investor, or really as a health consumer, that we all have the opportunity to shape the future of medicine. So I think I'll end with that. So please stay in touch if you want to chat more about it. Happy to do that. And I think we have time for questions.
Wow, fantastic. Yeah, I think that this is really a frontier in the twins in healthcare application. Yeah, I think that you may be the pioneer to integrating genomics with the digital twin in the like a molecular and human gen level type. Thank you, Marlene. Okay, so we are almost time, but we are going to have because we have a lot of questions already in chat. So we are going to have about 10 minutes to I will look it over what was the question. And if you have any like a question, you can raise a hand. Okay, so the first one was that how might the future is supposed to be like a shape and begin to work in clinical setting where digital twin data is imported to the digital twin models of their patient population. Okay, so yeah.
Yeah. So let me see. Are we going through the questions? Okay.
Yeah, question that starting from the first one.
Yeah.
Yeah.
Yeah, so I guess I can just speak a little bit to this. The digital twin data right now is kind of one of the studies we're looking at is how we implement this in a clinical setting, really feasibility of it. You have to start with clean data. Unfortunately, EHRs are pretty difficult to work with. And so for us right now, we have to start with our own clean data and transferring that in this, just from a clinical trial perspective. Eventually, we have to integrate with different electronic health records and systems, which is also a challenge in itself. But for sure, we are directing it in a very specific patient population right now and limiting it to that for the purposes that with genetic data, we know that a lot of it is based on certain populations. And for our study, we're trying to address really in the Emirati population. So I think with us, the population specificity is very important because we're combining genetic data with it.
Mm-hmm. Yeah. Actually, I had a webinar a few weeks ago with my another business partner. Actually, we are very interested in how to utilizing like a EHR data for the population health management. So we found that it's very as you talk about very difficult to manage the EHR data for your proposed whatever because a lot of the EHR data is unstructured and then to make enable to it using the AI particularly is very difficult currently. So we need some expertise to handling the data and gathering and the clarifying and even the data exchange or the interpreter have a problem. But if you have some problem with it, actually, I have a partner to have expertise for the space. So just let me know that we can have for that. Okay, so next question is, can digital twin in healthcare enhance and supplement or eventually replace these complex and expensive GWAs? What is meant by the GWASS? I don't know about this terminology, but yeah. May not, but can you give the more clarify of this your question.
Okay, yeah, I think I saw, okay, you were referring to GWAS studies. So again, GWAS studies are very much rooted, or because we don't have much diversity in genetic data at the time, it actually could be biased. And the answer really is, starting with your genetic data, we need more diversity in our genetic data. And not to say everyone should get their genetic testing done. But I think it's one way that we could actually address this. And once we have those that data available to us, then you can actually use this technology with AI to run these studies more effectively.
Additionally, because in general, because I've had a lot of I've been in technology for more than 30 years after my PhD. And actually, I'm alive to my LLM. I did my PhD in Johns Hopkins, and then but actually, the technology is kind of like to whatever that there as innovation happen, they can be like some complementary and supporting, but never seen that actually the technology can replace anything for some others, right? So might be they can be enhanced or maybe help, but then maybe not completely replace anything. That's my expectation. But anyway, okay. Oh yeah, slide. Yeah, mine is already, and then it's up to each speaker. So, but I think that their presentation is very explanatory itself. So I'm going to share the recording, so you can see the recording. That'll be enough for the. But otherwise, you can contact each speaker. Okay, so this is my. Okay, so I will look at that one. Patient report notoriously inaccurate. Oh yeah, patient report. Okay, so we'll provide real-time dietary intake and hydration data. Might wear. I don't know about the specific brand of might wearables. Post verification.
I think he may be just referring to how wearables can provide real-time
Yeah,
data.
but anyway, because one thing that was particularly that I'm interested into like a data import is I have researched the DTX for a year for intensively and look at the whole like a DTX innovation, and particularly the mental health space and other like for example developer disorder like the children's ADHD and autism. Actually, a lot of the diagnostics of these disorders are based on patient questionnaire answer, something like that. But actually, I found that there are a lot of the innovation happened because of the people like tended to like lie about their answer, for particularly for the mental health care cases. So yeah, so I think that in that case, there were a lot of innovation actually. How you can overcome that difficulty to automatically gather the information. For example, indirectly utilizing your whatever you like everyday like a sensing data, or sometimes your texting data, whatever then can be utilizing for predicting something in data. So yeah, that might be a proper
Can I make a comment? Can I make a comment here? Yeah, I work at Nationwide Children's Hospital and the Ohio State University College of Medicine. So I'm a professor of medicine here. I think the three presentations are wonderful, and you gave us some insights about the new development. I have two comments here. One is in our experience indicated, unless you got a buy-in of the doctors and physicians or psychologists, and this will pave the way to integrate this into clinical practice. Without integrating into clinical practice, this will always be in the research domain. So that's one comment. Another thing I was thinking about, our life complicated, and giving the Surgeon General's warning, the proposal to have a labeling about social media and all that, I worry about maybe this could become too overwhelming, and then people say, hey, this is kind of like too overwhelming for me. Over the past 5 to 10 years, social media and all this online things become so prevalent, and the mental health issue among youth actually skyrocketed. So that's something, two things for all of these great thinkers to consider. So.
Okay. Yeah. Thank you. Yeah.
I just had, oh, sorry, I had a comment on the wearable. I think capturing accurate data and even processing messy data is always the challenge. But I do think there are some innovations on recently, right? Like with the human AI pin. I'm sure you all heard of that one. I think we're moving gradually to a world where we're capturing certain things ambiently. So imagine like wearing Ray-Ban glasses that's from like Meta, right? That is audio capturing or like sensing what is around you. I think through those things, you can be a little bit more accurate and don't have to depend on the patient reporting like how many cup of water that I drank each day. I probably don't even remember really to accurately report that, but my human AI pin can kind of like monitor what is around and really pick up, hey, you're making you're drinking water right now, right? So that's like one record. So I think in terms of wearables, we'll start moving towards more like implicit capture data that could become actually more accurate source of data because it's not depending on us like doing it actively. So I think that is going to be very interesting. And the other thing I think a lot about like healthcare is really how do you we all know that healthcare can benefit from a lot of individuals' data being contributed, but we also want to protect like privacy and confidentiality of the user, right? So like how do we store certain things on device, or maybe I have my medical records like on my Apple phone connected to my medical records, right? But if there is a provider who is asking for this for research, perhaps I will be willing to supply that because, I may help someone else, right? But being able to keep that like confidentiality and privacy and transmitting it away that can anonymize, but directly from my device, I think is also very important. So I do see a world where like each of us will hold our own kind of healthcare device. Maybe a lot of it's on our phone already and a lot of in the wearables. And then we can choose to contribute certain data into research studies and into, epidemiology studies as needed, right? But all of those take a very user-centric view for like processing data and having the data itself.
Okay. And there are some questions actually relate to for the digital twin for animal or the pet. Yeah, definitely, because I already and Sharon already talk about the digital twin is the digital replica of anything is an entity, human, animal. But actually the problem would be the how actually the providing some data actually representing some entity, like for example your dog. And I'm not sure whether your dogs, depending on the breed. My dog is a beagle, and then if you wanna, maybe I'm not sure whether you can have like individual level data or whatever. But anyway, if your data is available, can represent something, right? Because for example, the digital replica means many things. So digital replica can represent whole thing or part, whatever, right? So if you want to represent your entity, and then you need some data to can actually can provide the situation or whatever about that things. Like for example, if you want to like mimic your dog's like some habit, then you need to provide the data about that, right? So, but anyway, because in general you can do that if you have a data. Okay. Will digital twin be addictive? I'm not sure. Because usually the digital addictive, maybe if you have an addictive, it can be the like. I'm not sure what the whether is digital twin be addictive means that you will be addictive to the digital twin, or you can be modeled for the addictive. But particularly the easy one is you can using your like a behavioral health data to make your digital twin, and then you know that there are a lot of the like digital therapeutics solution to for helpful like a behavior health model. So more yeah, like for example, you have an addicted for some like some drug and smoking, whatever, then you can utilize data for to developing the digital twin, and then you can develop your digital therapeutics to over digital twin to you can test it or whatever. But I'm not sure what is the question for the addictive. Okay, so maybe we have already have a pass over. There are so many questions here. Um, okay, so the best way that is to I will share this question in my LinkedIn site. Actually, that I will be post for the like where you can find the link for this recording, and then put it there, and then I will be like the tag all of you attendees here and speakers, and then put it in this question, right? And then you can discuss after this meeting about whatever you can give your comment, your answer, your question, further question, whatever you want. So you will have to post our webinar. Will be another session will be in the virtually in my LinkedIn post. So I will prepare for that. Okay. Okay, so thank you for attending today's webinar, and particularly thanks to Sharon, Marlene, because for example, Marlene is in India and Sharon in San Diego. So and a lot of attendees. Today's I didn't know that today is a holiday. But anyway, so, okay, so thank you again, and I hope that you have a wonderful day. Thank you, and see you
Thanks.
in my next webinar. Okay, thank you. Bye bye.